Okay, so this little video is about just what scalars and vectors are. And so in physics, we start using different quantities, we do use different measurements, and in this we can describe these measurements in terms of like scalars and vectors, okay, are different variables that we are using. And this is two different ways that we can categorize them, so either as scalars or vectors. So we're going to look at what they mean and some different examples to also explain them. So a scalar is something that is a magnitude only. So by magnitude, I mean the size of something. So for example, that could be like with a temperature. So a temperature, if I was to give its magnitude, it could have a temperature of 10 degrees Celsius. So that would be a magnitude, the 10 in there. Okay, it's quantifying the amount of it. It could be a speed. It could be traveling at 5 meters per second. Okay, so again, it would be a size. It's a magnitude in there. It might be that something has been moving for 30 seconds. Again, that is a magnitude, so it is a scalar in terms of the size. So we're looking at a value, so a size or a magnitude. Okay, so scalars are magnitude only. Okay, and that's really important because a vector, they also have got a magnitude, but they also have a direction. And you might be thinking, well, how do I know that yet? So we're going to look at some of these examples so that you can get some examples of where vectors are and what scalars are. Okay, so I'm going to start off with two of the most famous kind of ones that you probably have done in class, which is speed and velocity and distance and displacement. Okay, so speed is a scalar and velocity is the vector version of speed. Okay, so speed is a size. If I was looking at speed, I could say like something is traveling at 5 meters per second. It could be traveling at 10, let's say kilometers per hour. Okay, it has just the magnitude. It's just how fast it's traveling. So speed, I only just need to know about how fast that thing is. Whereas the velocity will be taking into consideration which direction it is moving in. So in this case, it could be 5 meters per second, and we might give it an actual physical direction. So we might say to the left. Okay, we could say things like forwards. Okay, I could say it's moving northeast. So I might start putting some different descriptions with it. Sometimes though, for these velocities, we don't actually use the language there. We sometimes use a positive and a negative value to represent the direction. So for example, if my car was moving forwards, I might say that it's traveling at 5 meters per second. But then we have a second car traveling in the opposite direction. That would be minus 5 meters per second. Okay, so sometimes we also use that positive and negative instead of using the language there. And that positive and negative is where I have, as the person looking at the problem, has defined it. So in this situation, I define positive as moving forwards. I could make positive going upwards, I could make positive going downwards, I could make positive going backwards. Okay, I define where positive is. So if it was moving to the right in this question, I said that was going to be positive. So I said that one was 5. So any objects moving therefore to the left were negative. So that's a little bit more complicated there, but it is something that we take into consideration in questions later on. The other one then is distance versus displacement. So I'm just going to move this up a little bit, and hopefully you can sort of see down here, I've got a person and they started at position A and they've gone along this little path down here all the way to position B. So this is the magnitude of which the person has covered. Okay, so this up here would be the distance. Okay, this is the distance that they have travelled. Okay, so that is giving me the size of the way the person has gone. But if I was to look at displacement, which is the vector, that also tells me the direction. So to look at the displacement to go from A to B, I would simply do a line going from A to B, which tells me the direction that they have gone. And this down here is the displacement. Now this can sometimes seem really different because the distance and the displacement have different values, okay? And that's absolutely fine because the displacement is telling me the size of the direction that it has gone in, okay? So that magnitude doesn't have to match the distance, okay? It's just telling me the magnitude of the direction that they have gone. So that would be the displacement. So a nice little example for this, for example, is if somebody has started in position A and they go all the way around in a circle back to position A and stop, well, in this case, their distance, okay, is going to be equal to the circumference of the circle. Their displacement is going to be equal to 0 because they have gone all the way around and ended back in the same spot. They have displaced nothing. Okay, so the vector version of distance is displacement, and because that takes into consideration the direction in which they have gone. Okay, and we'll come back to that problem later on when we do acceleration, and we talk about why things accelerate, for example, in a circle. So other examples then of scalars. So one we used before was the idea of time. So time is a magnitude. Vectors, something else that we have covered, are things like forces, because forces, they have a direction, so they can be moving down, they could be moving to the left, to the right. Okay, so forces also have a direction, so they are vector, which means if I'm looking then, that would mean weight, because weight is a force, whereas mass, just being the amount of kilograms that something is, that doesn't have a direction, so mass would be a scalar. Okay, other ones that we said for scalar was things like temperature, because that just tells me the value of what temperature the object is at. Another for vector, something that we're going to do again, is momentum. Okay, so momentum is also a vector. Another one for vector that we're going to be using is also acceleration in this little unit. So also acceleration being one of our vectors. You can look at lots of different ones to put in for these in terms of your scalars and your vectors, but these are just some common examples there.